Hi! In this exercise, we are going to calculate the inverse of a matrix using the three existing methods. Number 1, using the definition of inverse. Number 2, using the Gauss method. And number 3, using the determinant. Depending on the studies you are doing, you may need to know all three methods. However, if you only need one of them, I leave the minute mark in the description where I start explaining each method, so you can skip directly to it. You'll see that you'll understand them perfectly. Be careful because the thermometer is still in the orange zone. Let's work through this video together, and soon we'll be ready to confidently tackle any exam on this fascinating topic called matrices. Welcome to Binnacle Project.
Binnacle Project.
Let's begin using the first method. How is calculating the inverse of a matrix using the definition? Well, from when we were very little, they told us that multiplying a number, for example, number 5, with its inverse, it must be equal to 1, because let me remind you that the inverse of 5 is 1 divided by 5, and 5 times 1 divided by 5 equals 1. And this is the argument we are going to use to calculate the inverse of our matrix, that is, matrix A multiplied by its inverse must be equal to 1, but number 1 in the matrix world is the identity matrix. This is the way we are going to walk. First, let's copy matrix A. 1, 0, negative 1, 2, negative 1, 0, 2, 0, negative 1. And now we are creating a template for its inverse. A, B, C, D, E, F, G, H, I. And it must be equal to the unit matrix of order 3. 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, obviously, we are going to multiply both matrices, and we are going to equalize all its position to the unit matrix. Now it's time to multiply the left side. The result of multiplying two 3 by 3 matrices will be another 3 by 3 matrix. You know, I like to set up the template for the matrix I need to build to avoid missing any positions. And once the setup is done, let's get to it. This is a 3 by 3 order matrix, and let's go ahead. Position 1, 1, row 1, column 1. 1 times A, 0. Negative 1 times G is negative G. The result is A minus G. A minus G. Second position, row 1, column 2. Row 1, column 2. 1 times B is B. 0 times E, 0. Negative 1 times H is negative H. B minus H. B minus H. Third position, row 1, column 3. C, 0. Negative I. C minus I. C minus I. Fourth position, 2 times A minus D and 0. 2A minus D. 2A minus D. Position 2, 2. Row 2 and column 2. 2 times B minus E and 0. 2B minus E. Position 2, 3. Row 2, column 3. 2 times C minus F and 0. 2C minus F. 2C minus F. Position 3, 1. Row 3 and column 1. 2A, 0, minus G. 2A minus G. 2A minus G. Position 3, 2, row 3, column 2. To B minus H. To B minus H. And finally, position 3, 3, row 3, column 3. To C minus I. To C minus I. And obviously, we are bringing the unit matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. And that's it. Now it's time to equate the 9 positions, and a system of 9 equations with 9 unknowns will appear, whose solution will of course be the inverse matrix we are looking for. Don't worry, it will be easier than it seems, you'll see. Let's start. A minus G equals 1. B minus H equals 0. C minus I equals 0. 2A minus D equals 0. 2B minus E equals 1. 2C minus F equals 0. 2A minus G equals 0. 2B minus H equals 0 again. And finally, 2C minus I equals 1. And this is the system that we are going to solve in the next few minutes. I think it will be very useful for us to number our equations. Number 1, 2, and 3, 4, 5, 6, 7, 8, and 9. And even if it seems impossible to solve, you'll see that with a little patience we can solve it in minutes. Look at it carefully and see if you can come with any ideas. I'm starting to see that equations 1 and 7 share the same variables. How about we group them together and by applying a simple method solve for A and G? For example, look, from equations 1 and 7, let's put them together. A minus G equals 1, and 2A minus G equals 0. Can you see the variable G alone? I think it will be very useful to subtract both equations, and look what happens. A minus 2A is negative A. Negative G minus G is negative G plus G, and it disappears. And 1 minus 0, 1. And there we have the variable A. A equals negative 1. And of course, it's time to solve for G. Negative 1 minus G equals 1. I want you to imagine that variable G flies to the right side in the form of G, positive G. And this 1, positive, flies to the left in the form of negative 1. G equals negative 1 minus 1, negative 2. And there you have G equals negative 2. You see that it's very simple, right? On the same way, you can see that equation number 2 contains variables B and H, the same as equation number 8. Let's put them together. From equation number 2 and number 8, let's put them together. B minus H equals 0. And 2B minus H equals 0 again. Let's put them together in order to subtract them. And you can see that variable h will disappear. b minus 2b is negative b. The h disappears. Negative h plus h, 0. And 0 minus 0, 0. b obviously equals 0. And if we use this result, for example, in equation number 1, 0 minus h is also 0, where h equals 0. Easy, right? And finally, I'm sure that you have already seen that equation number 3 contains variables c and a, the same as equation number 9. So let's put them together. From equation number 3 and number 9, c minus I equals 0, and 2c minus I equals 1. We're going to put them together again. We are subtracting, as this variable is alone, and there we have variable c. c minus 2c is negative c. Minus I minus minus I is minus I plus I, 0 again, equals 0 minus 1 is minus 1, negative 1. And there we have, let's change the sign both sides, c equals 1. And for example, in the first equation, 1 minus I equals 0. Just imagine the variable I flying to the right in the form of positive I equals 1. I equals 1. Right? Since I ran out of space, I put the previous results on top. Well, why don't we use equation number 4 to know the value of variable d, as we already know the value of a. Let's use equation number 4. From equation 4, 2 times a, that is 2 times negative 1, minus d equals 0. That's it. Negative 2 minus d equals 0, where you can imagine variable d flying to the right in the form of d equals negative 2. d equals negative 2. See how easy it is? Of course, we are going to use equation number 5, as we already know the value of variable d. From equation number 5, 2 times b, that is 2 times 0, minus e equals 1. I also want you to imagine variable e flying to the right in the form of positive e, and this one flying to the left in the form of negative 1, where you can see that e equals negative 1, 0 minus 1 is negative 1. E equals negative 1. And finally, we are going to use equation number 6. From equation number 6, 2 times c, that is 2 times 1 minus f equals 0, where I want you to imagine this negative f flying to the right in the form of positive f. F equals 2. F equals 2. The system is already solved. And of course, the solution of our system is our inverse, the inverse matrix of A that we were looking for. ABC, that is negative 1, 0, 1. DEF, that is negative 2, negative 1, 2. GHI, that is -2, 0, and 1. And that's it. Even though it may seem complicated, fortunately we didn't rely on any happy idea, which could block you in any exam. We simply thought that A multiplied by its inverse must equal the identity matrix, and from there we just work through it. And that's it. And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!